Hi, and welcome back. In this video, you will learn how to detect the language of a text and about machine translation. You've already learned about several use cases for Amazon Comprehend in this course. You can also use it to detect the language of a text. Amazon Comprehend uses a pre-trained model and can detect 100 different languages. When Amazon Comprehend returns the detected language, it also returns a confidence score for the selection. In addition to Amazon Comprehend, there are several Python packages you can use to detect the language of a text. LangDetect, spaCy, and FastText all include libraries you can call to detect a language. Here you have a screenshot from the Amazon Comprehend console showing language detection. The code snippet shows how you can use the LangDetect Python package to detect language. Amazon Translate is a neural machine translation, or NMT, system. The system uses a pre-trained model and can detect 100 different languages. The slide shows an example of language detection in the Amazon Translate console. You can also generate translations by using the AWS Command Line Interface, or AWS CLI, or the Application Programming Interface, or API. There are two approaches to machine translations: statistical machine translation, or SMT, and neural machine translation, or NMT. SMT starts by creating a model of a source language that is based on a very large set of previously translated documents. Once you have the model, you can then apply it to new texts in the source language to predict the translation in the target language. These predictions are based on probability theory. SMT is based on translations of individual words and phrases. The SMT system builds a translation table which lists the frequency of word combinations in the source language collection. Phrase translation with a higher frequency in the source collection have a greater probability of being correctly translated than those with a lower frequency. There are several problems with SMT systems. First, they're not well suited for understanding the influence of context on meaning. Also, the accuracy of the translation depends on language pairs. For example, English and Spanish might work better than English and Mandarin. Finally, SMT systems do not work well with languages that have dramatic differences in word order and sentence length. NMT systems use neural networks to learn a model based on previous translations. As you learned about in Module 2, neural networks include two sets of nodes, one for an encoder layer and one for a decoder layer. Most NMT systems are built with recurrent neural networks. NMT systems are better at understanding context than SMT systems, as they can capture the context in a vector and then apply that vector to multiple language pairs. NMT systems are generally an improvement on SMT systems, which were developed before neural networks were in wide-scale commercial use. There are, however, still several challenges. Long sequences of text, for example, very long sentences, can cause the network to forget the earlier part of the sequence. This can be mitigated by introducing an attention layer, which was discussed in Module 2. Next, large or specialized vocabularies are still a problem for NMT. NMT systems are resource intensive and require long training times. And finally, NMT systems still struggle to provide translations for low resource languages. In this section, you looked at tools for detecting and translating language. You also learned about two different methods for translating text: statistical machine translation and neural machine translation. Thanks for watching. In the next video, you'll learn about two different Amazon services you can use when working with language.